Hey Algebra 2, today we're going to be talking about solving right triangles, okay? Solving right triangles. Well, we have our triangle here again. Angles are capital letters, sides are lowercase. I'm going to give you some information here. So the measurement of angle A is 65 degrees and C is 140. A good thing to do is to just label your diagram. So it was 65 degrees here, C now becomes 140. And we need to find A to two significant digits. So now we have to figure out, we need to set up an equation, but we need to figure out, are we using sine, cosine, or tangent? And the way we know which one is by think about the information given. From angle A is opposite, and we know the hypotenuse. So opposite over hypotenuse, so we know that's going to be sine. So the sine of 65 degrees is equal to opposite A over 140. Okay? Wish I probably should have my calculator on me here. Well, now we need to get A by itself, so we're going to multiply this by 140. So multiply both sides, so that cancels out. So now you're left with A is equal to 140 times sine of 65 is about 126.882. But notice the directions over here says find A to two significant digits. Significant digits, what that means is you're going to look at your front two numbers and you're going to round to whatever. So you're going to use this third one to either round up or down, and everything else becomes 0. So if I want to find A to two significant digits, this would round this up to a 3. So my final answer would be 130. Okay? 130. So that would be my final answer. That's how you do significant digits. Now the next problem says A is equal to 17, B is equal to 23. So let's put our information in there. A is 17, B is 23, and I'm asking you to find the measurement of angle A and the measurement of angle B. So now we're actually trying to solve for a side. So let's talk about from A first. From A we know opposite and we know adjacent, so therefore we're going to use the tangent. So we're going to say the tangent of A is equal to opposite, 17, over adjacent, which is 23. But now we need to figure out what A is. So whenever you're solving for an angle measure, okay? When you're solving for an angle measure, we're going to use this button here on your calculator. It's called the inverse tangent. And we're going to take the inverse tangent of 17 over 23, okay? Inverse tangent of 17 over 23. So if you were to work this out on your calculator, you'll get 36.469. But when we're dealing with angles, at least for me, I like to round it to the nearest degree. So we're going to say this is 36 degrees here. 36 degrees. But notice I also have to find angle B. But the thing about angle B is that these two angles in a right triangle will always add up to 90. So instead of having to do all the work again to find angle B, I just do 90 minus 36, which gives me 54. So I know this is 54 degrees. So again, do the inverse tangent and then subtract from 90 to find your other angle. So that is how you do, that's how you solve for an angle in a right triangle. Okay, so the next example says, a plane is flying at an altitude of 24,300 meters. From the plane, the measure of the angle of depression of a ship is 55 degrees. How many meters to three significant digits is the plane from the ship? So, best thing to do in this situation is draw it out. So we have nice little water, woo, and then we have a ship. Okay. This is a very, very sad looking ship, but there we go. And we have a plane over here. Okay, I am not an artist, so I apologize. So, the plane is flying at a certain height, okay, 24,300. But if you think about it, that's the same as the height here. Okay, so we're going to create a triangle here. So we're presuming that the plane is flying in a straight line. So 24,300 meters high. From the plane, the angle of depression of a ship is 55 degrees. Well, what does that mean? What that means is that the angle from the top, see how these are pretty much parallel? These two lines are parallel. from the top going down is your angle of depression. Okay, this is your angle of depression. It says that this angle right here is 55 degrees. Okay? Again, this is your angle of depression. This angle right here would be your angle of elevation. Okay? So there's angle of elevation from the bottom moving up, that angle, and angle of depression is from the top moving down. Okay? And one other thing, extra thing that you should know, is that the angle of depression and the angle of elevation are always the same. So if this is 55 degrees, this is also 55 degrees. But anyways, so it says, how many meters to 3 significant digits is the plane from the ship? So we're actually asking this distance right here. How far away is that? So here, we have to set up an equation here. So from the 55 degrees, we know the side opposite, and we're looking for the hypotenuse. So that would be sine. So the sine of 55 degrees is equal to opposite over the hypotenuse. But notice here that we have x in the denominator. So if we have an x in the denominator, we want to get it out of there by multiplying. So now we have x times the sine of 55 degrees is equal to 24,300. So lastly, to get x by itself, we need to divide by sine of 55 degrees. Okay? So that crosses out. So if we were to work that out on our calculators, you get x is about 29,485.776. That's approximately. But notice in the directions it says how many meters to 3 significant digits. So to 3 significant digits, what is it? So this rounds up. So we know our final answer is 29,500 meters. Okay? That is the distance between the plane and the ship. Okay? 29,500. That's how we do it. Again, you have to set up an equation, figure out from your angle what information do you know, what information are you looking for. Opposite we know, over hypotenuse, so we know we're going to be dealing with sine. Alright, let's go to one last word problem. This is actually quite a bit of a tougher one, but I'm sure we could figure it out. It says the captain of a ship wants to determine his distance from shore. So, here's the ship, okay? Here's the shore. We know that there's a distance here. It says, seeking a familiar landmark, he finds a 90-foot lighthouse on top of a cliff. So first of all, we have our cliff here. Okay, that's our cliff. And now we have an extra lighthouse. I'm terrible at drawing these things. We have our lighthouse. Alright? So we know that this distance here, the lighthouse is 90 feet high. The thing is, we don't know the height of the cliff. So let's finish reading here. He cites both the top and bottom of the lighthouse. The measures of the two angles of elevation are 46 and 39. How far to 2 significant digits is he from the base of the cliff? So, again, he sees the bottom of the lighthouse. So this says this is going to be the smaller one. It's 39 degrees. Okay, that's a 39 degrees. And he also finds the distance to the top, or the angle of elevation to the top of the lighthouse, which he figures out is 46 degrees. So here we have 2 triangles, but we need to set variables here. So let's say the height of the cliff, so just this distance, let's call that h, which makes the height of the bigger triangle h plus that extra 90 feet, the height of the lighthouse. So what are we looking for? So it says how far to 2 significant digits is he from the base of the cliff. So let's call that x. How far is he from the base of the cliff? Well, we have 2 triangles, 2 right triangles here. We have one right there. I'll draw the other one in red. Okay, the other one looks like this. And it goes down. Okay. That's our other triangle. So we're going to set up an 2 different equations here so we can solve this. So let's talk about the smaller one first. The 39 degrees. So the black triangle. We need to know the height, the opposite, and we need to find the adjacent. So opposite over adjacent is going to be tangent. So the tangent of 39 degrees is equal to the height of the cliff over x, which is the distance from ship to shore. That's one equation. Now the other one, the red triangle, okay? So the red triangle, same thing, tangent of 46 degrees. But now the height of this triangle is h plus 90. But it's also over the same distance, x. Okay. Now again, we're trying to solve for x. This is the main thing that we're looking for. So we need to get h out of there. So the best way to get h out of there is set both of these equal to h. So first, I'm going to multiply by x on this side. So I get x tangent of 39 degrees is equal to h. So we're done with that side. Now here, multiply by x. So we get x tangent of 46 degrees is equal to h plus 90. But again, we still need to get h completely by itself. So we're going to subtract 90. So x times the tangent of 46 degrees minus 90 is equal to h. And again, the reason why we did this is now since both of these are equal to h, we could set them equal to each other. Okay, equals x tangent of 46 degrees minus 90. Now what you could do is on your calculator type in tangent of 39 degrees. Grab my calculator. So the tangent of 39 degrees is going to be 0, let's go to 4 decimals, 0.8098 x, okay? So this is what, so tangent of 39 degrees is equal to that. Tangent of 46 degrees is going to give us 1.0355 x minus 90. Okay, so now what we can do here is let's move the, actually let's just move this way. Subtract the 1.0355x, 1.0355x. That cancels out, so we have 0.8098 minus 1.0355. We're left with negative 0.2257. Sorry, x is equal to negative 90. So our last step to solve for x is to divide by 0.2257. Negative 0.2257. Negatives cancels out, which makes sense. You can't have a negative distance. So if you end up with a negative, there's something not right there. And we end up with x is equal to 398.76. Okay? 398.76. So what we have to do is look at the directions. Always go back to the original problem and ask them, or see if they're asking you to round to a certain digit. Here it says, how far to 2 significant digits is the captain from the base of the cliff? So we're worried about those two numbers. So this means we're going to round that up. So our final answer, he is 400 meters away. We are dealing with meters, right? Yes. Oh, no, we're dealing with feet. Okay, 400 feet. There you go. So again, I know this is a much harder type of problem because you have to set up 2 separate equations and eventually set them equal to each other. But the best thing to do is always draw your diagram. So we have a smaller triangle setting up with tangent. We have our bigger triangle setting it up. We're also going to use tangent there. We got h by itself, so therefore we could set them equal to each other. We change these to decimals by typing tangent of 39 into our calculators, and then we solve for x. And that's the distance we're looking for. So the captain is 400 feet away from the cliff. So this is how we deal with solving right triangles, especially when it comes to word problems. So good luck with that, and please, please, please let me know if you have any questions at school. All right? Have a good day.